There are essentially two ways of analyzing JavaScript in the context of bug bounty and cybersecurity. One of them is static analysis, which is where we actually download the JavaScript files onto our computer and then basically perform code review on them, searching for vulnerabilities, running some kind of regex on them, looking for endpoints, and basically stuff like that. The other type is called dynamic analysis, and this is where we actually analyze the JavaScript as it's running inside our browser, typically using a tool like the browser DevTools, like Chrome DevTools or Firefox DevTools. And both ways have their distinct advantages, and in order to basically get a full understanding of the website and basically be thorough with your search, I recommend using both options, as they're really going to help you. I've already touched a lot on static analysis of JavaScript with stuff like JS Scout, pulling JavaScript files onto your computer or running like the JavaScript bookmarklets, but I haven't really touched a lot on dynamic analysis, which is really what I want to cover today. Basically, how to use your browser DevTools to perform dynamic analysis. Right, here I am in OpenAI, and it actually doesn't matter what application you're on. I'm just going to use OpenAI just to showcase the JavaScript analysis. Basically, every website nowadays is JavaScript, so you can go on any website and try this out. But if you want to follow me, you can go on OpenAI, and you can just sit here on their like main page with this like ChatGPT looking thing here. And to actually open the DevTools, if you're in Firefox, the shortcut is Control-Shift-I. So if you press Control-Shift-I, it should bring open the DevTools for you, like so. And you should be, first of all, if you haven't opened the DevTools before and selected these tabs, you should be in this tab called Inspector, right? And this is kind of the main tab here, which I'm going to show here, and the one that most people don't actually leave. And what this tab basically does is it shows us the DOM. So the DOM is the document object model, and it's what actually gets displayed on the website, right? So this is all the actual elements of this website. So if we hover over like over this thing, we can go inside and we can see like this article here. We can see like these boxes on the side. If we go into this, you can see the actual chat box, and if you keep going, whatever. And a little tip: if you press Alt, if you hold Alt and press on one of these things, it'll open up the whole thing for you. So just a little bit of a way to save time. And this works on any one of these boxes in Firefox. So if you hold Alt and press it, it's going to allow you to basically expand the whole thing, which is kind of nice. And you can see we have like message ChatGPT here, and we have the box that's actually here as well. So the document object model just displays the HTML. If you don't know what HTML is, then I made a video about it before. It's pretty important to know as a bug bounty hunter, so you should look into that. But yeah, this is what displays the HTML here. And there are a few things that we can do to debug this. And debugging HTML is something that a lot of developers do. It's less important for bug bounty, but there are also ways that we can do it here. The first kind of cool thing is to actually see the events, right? So what you can do is developers can link HTML objects to JavaScript events through something like add event listener. So let's say we have a button, right? We have a button on this page somewhere, and we want to do something when that button is clicked. Well, what you can do is you can add an event listener to that button to listen when the button gets clicked, and then link it to a JavaScript function. And in Firefox, we can actually see what HTML elements are linked to what functions. For example, this HTML tag is linked to load. So when this HTML tag loads, this function will fire. If you want to see where that function is, we can click this little thing right here, which is like this arrow pointing to some source code, open load in the debugger, and it's going to show us exactly where that script actually is. So this function runs whenever the page loads. So that could be interesting to know. That's one of the cool things. What other events is there? Like for example, for the button, there'd be like an on-click event here, and when we went to see the source code, it would basically point us to that event. And this is native code. We'll touch on that a little bit later, but I'll just keep that for now. Message is like a post message, so this is also important, and that could allow you to do some debugging as well. Now obviously, since we're in the inspector tab, we can also edit HTML. So if you go in here, you right click something like this, you can edit it however much you want to. Let's say we have like another button somewhere, whatever, this button right here, and in this case, the button's like disabled or whatever. Maybe we can come in here, edit as HTML. Now maybe this is not going to work like this, but we'll see. And we can just say disabled is false, so we can actually click this button. If you press disabled is false, like so, hopefully, if we click now, okay, god damn it, that didn't work. Let me see, maybe we just get rid of the, oh, that's not what I wanted to do. Let's see, click in here, edit as HTML. I think maybe we just have to actually get rid of this disabled attribute entirely. So maybe that'll work. Oh yeah, that did work. Lovely. And now you can see here that this button is actually pressable. So let's say we have like a situation where, you know, there's a button and it's going to allow us to do something, but let's say we don't have like a premium feature unlocked or whatever. We need to pay for the service. We could go and pay for it, but what we could do is we could make the button enabled like this and then see if the thing actually allows us to do it anyway. Because maybe, for example, the block is only on the client side. That would allow us to do some like access control vulnerability testing. So that's a really good way of basically bypassing some of those really annoying things where it's like you need to have premium to do this, or you need to have like whatever permissions. So we can basically edit it as HTML. The other thing is, if you have, for example, a cross-site scripting payload in here, like let's say in this div that I just created by accident, we have like a cross-site scripting payload, then maybe we want to check if the payload is actually being sanitized, right? If it is being sanitized, then you'll probably see something like this, I think, where you'll have like an angle bracket, but it's not actually an angle bracket, it's being sanitized, right? So like if you injected this angle bracket, that could actually be a real angle bracket, or it could be a sanitized angle bracket. And if you click edit as HTML, it'll show you what it's actually looking like, which in this case it is sanitized, right? And I think the right angle bracket looks like this, if my memory serves me right. Yes. So for example, if I inject that into it and I edit it as HTML, we could check that it's sanitized. So it'd be cool to check your cross-site scripting payloads like that. And I think that's most of the important things from the actual inspector tab. Now, if you right click on elements, you'll see a lot of other things. Most of this is not relevant for bug bounty. You can add breakpoints to your HTML tags. And if you don't know, a breakpoint is basically something where, as the interpreter is running through the code, if it hits one of our breakpoints, then it's going to stop execution and let us examine what actually happened. It's what developers use to basically check their source code and fix like errors and stuff. So we could basically break on like whenever one of these nodes is modified, whenever one of the HTML tags gets modified, if one of the attributes gets modified, which is like that disable thing that I got rid of, or if one of them gets removed. I don't know why you would want to do that, but it is there anyway. So if you right click on that, you have a few things that you can do here. And yeah, you can just delete it, duplicate it if you want to, or you can add attributes yourself. Now one thing that is kind of cool is this use in console button. If you press this button right here, I'm just going to make that a little bit bigger. Hopefully I'm not blocking anything. Okay, I'm not blocking anything yet. Right, so we're here, and you see that it's giving me this this variable here, this temp variable. And when I click this run this code, you'll see that the actual article pops up here, right? And now, if I want to, I can basically use this. So say I can say like, I don't know, .inner HTML is equal to, I'll say like this. I can basically use this in code, and it's going to, okay, basically it's going to set the inner HTML to test. So that's a cool way to use tags in console without having to go through the normal JavaScript way of getting the tag, which is like getting it by the ID and stuff. There's actually even a faster way to do this, which I think is pretty cool. If you put $0 here, and you go over to one of these elements, like say this footer, I'm going to select it, and I press it, you'll see that this footer appears in the console again, which is pretty nice. But if I select this now, and I run it again, it's selecting this. So this $0 sign lets us basically use any element that we currently have selected inside the console, which is even faster than using it from the variable thing. So basically, if you want to use one of the things like permanently, so let's say you're going to be using like an iframe and you want to save it as a variable, then it kind of makes sense because you're going to be selecting other objects later. But if you just want to like quickly use like the same payload, then you don't even have to change your script. You can just select different elements, which is pretty cool in my opinion. Now currently we're just using the console from basically the inspector tab. We have it split in half, but we also have a dedicated console tab right here with an actual like full view. So if you don't need to use the inspector, you just need to use the console, you can head over to this tab instead. And I think this $0 sign still even works, so it actually remembers the selection I have here. So that's pretty interesting. But what this console allows you to do, if you haven't figured it out yet, is it allows us to run JavaScript files. Now, the context in which this JavaScript actually runs is quite important. And I actually picked a really bad example because this website doesn't have any iframes or web workers. But maybe I'll just come in here and actually add it in. I'll add like an iframe source is equal to yours truly, my little bug bounty labs. Hopefully I'll add an iframe so I can actually show you what it will look like if there's an iframe here. So if I run that, what happened? Oh my god. Hopefully if I run this, it's going to add an iframe here. And you can see here that something's happened, right? So we have this little drop down menu here. And I don't know if Chrome does this, but for some reason Firefox really likes to switch into iframes whenever you're looking at execution context, right? So what this is going to do, this is going to execute the iframe. Sorry, this is going to execute, top means it's going to execute the JavaScript on the top domain. So the domain that we're currently on, which in this case is openai.com. However, if we switch into this is now going to execute it inside the actual iframe. So the context is going to be different, right? There's going to be different scripts loaded in there. There's going to be like different, the window is going to be different. The object might be different. So there's basically a different execution context, right? And items that we access from the iframe are not necessarily going to be accessible on the top domain, right? So an iframe is not allowed to just like edit the HTML of the top domain, and the top domain is not allowed to edit the HTML of the iframe, right? So just remember, if you're like trying to run some like code, if you're trying to like do like this, for example, you're trying to like get like the HTML from the main site and you're trying to use it, but it's actually inside an iframe, you might have to switch it here. And if you want to like test post messages and stuff like that, then for example, if you think that the top domain is vulnerable, you might have to switch into the iframe and then do something like window.parent.post message like this. You might have to do something like that, because then we're going to be sending the message from the actual iframe to the top, right? Instead of, if we were at the top, we would be actually we would be basically sending it basically to itself, kind of, you know what I mean? That's what I'm kind of talking about. So we can just test that for a minute. I'm just going to say like test or whatever, and then I'm going to put this so it's whatever origin, and if you run that, you'll see it should have sent the post message in there. So we can send the post message from the iframe, we can send it from the top as well, and we can do that by switching the context here. And I'm going to refresh the page because I kind of broke this a little bit. So we'll just go back to the top here, and maybe there's something here actually. Yes, about blank. I think this might be a web worker actually. So now, what are the things that we can actually use this console for? Well, one of the cool things is to test those post message vulnerabilities, which is kind of the main way that I actually use this. So if you want to post message to like one of the iframes, this is really useful. Another way is to like trigger different functions from the JavaScript, and we'll get that in the debugger, like hooking stuff. If you want to like print stuff out, then you can also do console.log. We can just print it out here like so, and this is going to log it. So we can print stuff out like that, and it's going to log it to the console. Now, I think by default, if you go into this, if you have like a fresh Firefox installation, I think you'll see this a little bit differently. There's a chance that your code is going to be written here, and just to fix that, because it seems really stupid to me, I think you have to go to settings, and you have to click this button, so enable split console. And I recommend you do that because I don't even know how people code like that. Because if you do it like this, you know, the context is here, nice and all. You can like prettify your code, and you can also like search to your history. But if you have it here, then your code is actually colliding with the things that are printing out in the console, which seems really annoying to me. And here as well, you can do stuff like adding like variables like this, and then using those variables in the code. So you can basically have like multi-line commands for stuff that you might want to do in the console. And then you can do it like this, you see. So we're actually printing out two of them. That just seems really annoying to do when you're typing it here. So basically switch your console to the split view. And yeah, basically you can access elements from the DOM. And the more traditional JavaScript way of doing that, if you don't want to do like the $sign thing, is using something like this, where like declaring a variable and then having document.getElement either by ID, by class name or whatever, and you get element like this, and then you can like log it like that, and then you can access it as well. So that's something that you might want to do as well. So if you run that, see in this case there's none of it, but if we go like here, I'll edit this as HTML and I'll add ID is equal to test to it like that. Hopefully like save that. Oops. Hopefully that's saved. Like that. Okay, did not save. Maybe we'll add something else on. Let's say edit as HTML, header, and we'll say like ID is equal to test. Down. Okay, there you go. ID is test. Go here and you can see the header spot. So this is the more like traditional JavaScript way of doing it. And then I was talking about those event listeners. So to add an event listener, you can do add event listener, for example, on click like this, and then you can use an anonymous function. I think they're like this. Okay, my JavaScript knowledge is absolutely phenomenal. Hold on. I think it's like this, and then whenever we click that, it should be fine. Okay, hold on. Maybe I did that wrong. Maybe like this. Shimmer. Okay, whatever. On click. I think it might just actually be click like this. Okay, it's okay. It's just you have to actually get like a valid function here. Like, let's try message then. Okay, whatever. Doesn't matter. Whatever. You can add a event this and like that. Trust me, you can add one. Alright, it doesn't matter. I'll Google it later and we'll see. Wait, I think that's mostly it for the console. You can just execute JavaScript here. Remember the context that you're executing it in. Now, there's a few features I wish that there was here, and one of them is that like there's not really a history tab. So in Chrome, you can actually do something called like snippets. So you can save your code inside snippets, which I think is pretty nice. In Firefox, this isn't really an option, unfortunately. You can kind of do it by typing it in and then like searching it. So if I like pull up an A here, you can see that it's pulled it back, and I can go back and I can don't know what that is. You can you can find an A here and you can go back to it in your history tab. So maybe if you created like a JavaScript comment with like some like mad thing, and then if you, for example, ran that and then went to your history page and then searched that, it would bring it back. So if I got rid of this, like ran like nothing, then I went here and I bring it back and you can see. So maybe there's a way of like tagging your history like that. That could be an option, but I wish there was a better way of actually saving the functions that you're running, because some of them you're going to be running basically constantly, and there's honestly like there's should be a way to save it so you can run it like whenever you want to. But sure, it'd be better to have more things anyway. But yeah, we have to be happy with what we have, right? Anyway, some other stuff in the console. This is obviously where the console prints out its data. This is like the terminal, and we can basically filter for stuff here. So you can see we can filter for errors. You probably want to filter this out because unfortunately there's just so many same origin policy errors or CORS errors and CSP errors. So honestly, I usually just turn these off because they're not really helpful if you're not a developer anyway. I usually just have these three turned on. And if you want to get like even more technical with it, then you can filter for specific things, like I don't know, say message. It'll still show you all of the scripts that you ran. So it'll show you all the scripts that you ran, but it's specifically filtering the things that were actually printed out. So if I say like console.log and I'll say like message like test like this, you can see that it's going to actually add a quotation there. You can see it's going to filter out for message test, but if I printed it out without the message, it's also not going to show it because it's hidden, as you can see. Now, I really wish there was regex here as well. There's just so many things I wish there was in Firefox, but it's not. I really wish you could filter by regex, which I don't believe you can. I think this is just a plain string, so that's kind of annoying. You can press this button to clear the output as well. And yeah, I really wish you could filter by this regex, but I don't think you can. And there's just a few more things. You can see CSS, so these show you CSS errors. I don't know why you would want to do that. Maybe if you're like a CSS injection master, you can do that. But and then XHR, which is going to show you failed XML. I think it's like XML fetch or something like that. And this is going to show you those like requests. In this case, it's probably mostly going to show you random third parties like Sentry and Datadog. And then you can also see actual requests. So this is going to show you all like the fetching. And in this case, it's going to be showing me the CDN for OpenAI, which makes sense. I don't know if this shows you all of them. I think it does actually show you all of them. But you can also use the network tab for this, which we'll get onto later anyway. And yeah, I think that's it for the console. So now we're going to move on to the actual fun part, which is the debugger, which is literally the main actual way to dynamically analyze JavaScript. But just to start, I'll draw your attention to the stuff on the left, which is going to basically show us all of the actual scripts inside of this website. And you can see in Firefox it's broken down in this way, where this main thread is going to be the actual website that we're on. So this is going to distinguish between iframes. So this little box here means that it's a separate website, so it's an iframe, right? So we're going to go into the first iframe here. And these little this little globe, on the other hand, distinguishes what website it's actually coming from. So if we look at our main page, you can see if we go into like a script here, you can see it's importing a script with source on this website. So that means that this is on openai.com. But this could also be a script from a separate website, right? So if it was a script from the separate website, it would show somewhere here. In this case, somewhere Google Tag Manager is being imported, which is pretty common little tracking software. And if this was happening on an iframe, so on a different frame, it would be shown somewhere here, so on a different website. In this case, this about/blank iframe, or I think this is a web worker, is importing a script from openai.com. That's why we see it here. And commonly you'll see like CDNs here. You'll see most scripts are imported from like a CDN or from like somewhere else. So that's where you'll be seeing it. But in this case, we just have it here. And once you open it, you'll most likely see something like this, because every website likes to webpack things nowadays. It's not going to be very easy. So unfortunately, you'll probably see something like this. And also you can use the same trick here. If you hold Alt and press, it's going to open the whole website for you here. And then you can just go inside whatever file you want, or maybe just choose one that doesn't look as cancerous as the other ones. Yeah, sure, this one. And then obviously, hopefully you figured out that the script displays on the right hand side of the page. So that's it's here. Now obviously this looks terrible, so we're not analyzing anything right at the moment. So you want to come over here, and you'll see this button, pretty print source. Just be careful with this button, right? If you have an absolutely humongous script, pressing this button could literally crash your browser, which I've had happen a few times, so be careful. And also you might have source maps enabled. Source maps kind of just tell you basically, like they bring in some of the like actual real variable names, because this is all minified, and like comments and stuff like that. Now I usually have this disabled by default because again it could crash your browser. You know, my computer doesn't have that much memory, so I usually try and disable this by default. And if I want to do more like stuff on it, then I'll enable this. But I actually think that it's better to use something like JS Scout for that, because it kind of does it automatically and more efficiently. So I recommend doing static analysis on that. For dynamic analysis, I usually just press this button here, which is going to prettify it for us, which is going to make it a lot easier to read, which is very nice. And once I've done this, we are able to actually debug the JavaScript. Okay, let's say we have our function on the right here and we actually want to debug it. Well, how do we actually do this? Well, as far as I know, hopefully I'm actually right on this, JavaScript is an interpreted language and not a compiled language. That means that it's being executed line by line by the interpreter. So unlike a language like C, which is compiled into machine code, which is then directly executed as a binary, a language like JavaScript or Python is actually interpreted by another kind of program in the background so that we can basically debug it and get sort of like verbose error messages. And there's also more like protection basically happening in the background. And what that allows us to do is that we can actually come in here and pause the interpreter. So we can say stop. And it's going to pause at whatever point it's currently at. So whatever script it's executing at this moment. And usually this is going to be some kind of async function that's running in the background, right? In this case, when we paused the interpreter, it was right here on this line right here. And it was executing it. I mean, the interpreter is very fast, so it goes very fast to the program. So in this case, it was probably executing some like function that was recursively being called or something like that. And in this case, we're now debugging the function. So you just pause the interpreter at this moment. And there are some cool things to note, right? We have this script here, right? And you see, if I hover over things, you can see it's actually telling me what it is. So before the interpreter was executing the function, all of these these variables could be anything, right? So we don't know what their value is. But once the interpreter has moved through the code, the variables actually have a value. They're actually stored in the memory by the interpreter. So these actually resolve to something. And when we debug the code, we're actually able to see what these variables resolve to. So for example, we see that P is an object and it has a value called current, which is set to 73. So this is executing, I think, a given number of times or something like that. We can see the document. So this is the actual whole document that we're looking at the moment. And its values are also going to change as the interpreter moves through the code. And it's going to have like different elements. In this case, this dot hidden might change. This is checking if the document is hidden. And you can see these other minified variables like C, E, or stuff like that. It looks like it's a big array. And what this is really helpful for doing is if we have a function that we want to figure out, like what can we pass into this function? If we know when the function triggers, we just basically stop the interpreter at that exact point, and then we look at all the variables and we say, hey, like what is this? What is this? What is being passed into this, right? And that's a really cool way of debugging the code. Now, obviously, we don't really want to stop the interpreter anywhere because this is not really useful to us, right? Let's say we actually did want to stop it here, right? Now, instead of, just trying to like time it or something like that, that's stupid, we can do something called a breakpoint. When we set a breakpoint, the interpreter, whenever it reaches this line of code, it's going to have it like saved that it's going to pause at this exact moment. And that's going to let us debug it from that moment, which is really good. If we want to pause at an exact like function, we want to basically look at this specific function and see what values are going to be passed into it. Because at different points in the interpreter, these variables are going to mean different things. There's probably hundreds of variables called E in this script alone. That means that as we move through the code, the variable E is going to move different things. So when the interpreter is down there going here and checking the value E, this is not necessarily correct because this value E could mean something completely different up there than it does here. So that's very important to keep in mind, is that we want to pause the interpreter close, ideally inside of the function that we're currently in. So once we've set this breakpoint, we can basically run the interpreter again. So if you want to unpause the interpreter, you can either press F8 on your keyboard or just press this button here. And once you press this button, it's going to keep running the interpreter. And you can see we've actually halted again. So because this function is running a few times, the interpreter has stopped again. So we've told the interpreter to stop at this point because we've set a breakpoint. And you can see that we can have a look at these functions again. Maybe one of these is like changed or whatever. Maybe document is hidden now. Apparently it's not. And you can see that most of these have stayed the same. Let's say we pause the interpreter here instead. So unpause it, run it, and potentially it did not stop there, which is a bit annoying. If you go back here, see that the interpreter has completed that loop. Oh, we stopped again. So now we've stopped at this one. So we can debug this function again. And that's basically how breakpoints work. We can stop the interpreter at a point that we want it to stop, and we can inspect the function. Now I think I'm going to be blocking it, unfortunately, because I think there's a few things that I wanted to show you. I might have to move myself over here for a second. Let me just like, well, that's not what, hey, OBS, hold on, see, form, flip, okay, there you go. Okay, I'm gonna cover this side for a minute, but I want to show you cool things over here, which is some of the call stack. So, different functions get called at a different point, and we can see exactly what functions were actually called to get us here. And you can see there's a lot of interesting up functions, and we can also go to each of these functions and see what they do, right? So in order to get to the point that we were at with the interpreter, oh, it's a bit laggy. In order to get to this current place, so we're executing this function called current, we had to go through this function ij. Where's I actually? We had to go through another function. We had to go through ij, up, up. Okay, I don't know why that's happening like that. I don't know what the fuck OpenAI is doing here. But yeah, we had to go through all of this. So you can see the actual call stack of the functions that we actually ended up being at. So this is useful if you want to see like where this function originates from. If you're like debugging a certain function, you can see like what's going to be called before that function to actually get us here. And sometimes there's going to be like a top level function, which might be like an event handler. So for example, this function was called whenever we clicked on a button, and it like went down the call stack, and we ended up being here. So that's something you might see. And on this side, you'll see your actual breakpoint. So this is the one that we set right here. So here we can disable and enable it whenever we want to, like so. And we can also see the threads that are running. So at the moment, we're in the top thread. So this is the main one. And iframes in JavaScript have different threads. So thread is just like the code execution, like as the interpreter is going down. So in this case, you can just imagine like a thread being like two interpreters going down as like two threads. So we have multiple basically places to stop. In this case, we've stopped the thread there. Each web worker has its own thread. So web worker is something that a script can spawn out to basically run with something in the background, and that has its own thread as well. And it's common for applications to be multi-threaded nowadays, so using like multiple cores of your processor in order to just speed up performance and efficiency. And apart from the call stack, you can also see some of the scopes here. So this is some of the variables that are inside of it right now, and you can see this thing has the function e that we were looking at, d, p, p is this thing right here. You can see r was here. So inside this function, this current has like its own arguments and stuff like that. So you can see just the functions that we're looking at, and I think this is like the top level function that we were calling before. You can kind of see where these variables flow in from as well. And that's kind of mainly it for these breakpoints. You can kind of just press it and then debug it. Now, what is the advantage of doing this over just statically analyzing it? Well, from personal experience, I've tried to figure out like what values we're getting passed into a function. Because when you look at like a minified function, let's look at this one. You have l n dot memo, right? Like that could literally be anything. This n function, if you try to go into like Visual Studio Code and you do like search n, you'll get like a million results. But if I just went here and then just stopped the interpreter like here, I could see exactly what's being passed into the function. I could see what a function's returning, which could be very useful for basically looking like later down the line. If say I'm like debugging like some post messages, I could place my basically I could place my like debugger inside the post message and see what's like being sent over, see what what variables are inside the post message. Like let's say there's like a weird like regex thing saved somewhere, like it was like t.execute or t.match or something like that, and I couldn't find where the regex was. Well, I could just place my breakpoint inside the post message, just hover over that variable, and it would show me the exact regex. So that is just a way to basically save time. Basically, it's just a way to save time and not have to look for these things ourselves. So it's a great way of debugging it like that, and that's why I really like using breakpoints. So just unpause the interpreter there. And the other kind of breakpoint that I want to talk about is actually this thing, this conditional breakpoint. So let's go over here, and if you just right click on this, you'll see this little drop box come out. not Dropbox, sorry, this little like it's called like this like toolbox come out, and you can see we can add a normal breakpoint just like we added before, and we can stop the interpreter like that. We can also add something called a condition or a conditional breakpoint. And what a conditional breakpoint is in the terms of the interpreter, when the interpreter evaluates the condition that we put in here to true, it's going to stop. But if it evaluates to false, it's actually going to keep going. So in this case, let's just set a conditional breakpoint that is true. So this is always going to evaluate the true, right? If we just wait a second, the interpreter is actually going to stop here. It's going to stop. Now, if you remove that condition there, we go back here and add another one. Let's just create one that says false, right? But before that, I'm going to press the semicolon here. I'm going to say console.log, and I'm just going to say that I'm just going to log like test or something, like this, the classic. I'm going to leave a space between them. So if the interpreter goes through this, it's going to log test, but since the actual condition still resolves to false, it actually shouldn't stop. So I'm going to create this condition, and I'm just going to watch the console, right? And you can see that test was printed, but if I go to the debugger, the interpreter did not stop. So you can see that this is a way to basically stop the interpreter whenever we actually have a condition that we've met. And that's really good, as it allows us to basically do debugging that way. So say, for example, we're looking at a post message, we add this conditional breakpoint, and we say like only break if, for example, the condition, the message is like this or something like that. We can like do debugging that way, and this is helpful, but it's actually even more helpful in the following way, right? We can actually execute JavaScript in this context and actually see what happens. So let's say I'm in here and I'm going to say e is equal to false, and then I'm going to set this to false itself. And I might actually set it up. If I set this like this and say I put a breakpoint here now, you can see, sorry about that, I actually just set it back to false. Hold on, let me actually edit that condition and set e to true instead, just to see if some weird things happen. We'll set e to true, update it, run the condition again, see, and you can see e is now true. This is a way of basically changing the value of these variables as the interpreter is running to see what kind of changes in the code happen. And maybe then we could look for some kind of injection point, some kind of client-side vulnerability to change the value of that variable for the user if some kind of weird stuff does happen, if we unlock some other code path, right? So this is a cool way of basically doing that, and I think it's very handy. So basically, instead of running it from the console, we can run it from the debugger in the exact context. And this is good if you want to like hook a function. So if I want to like call like a certain function from this, but I don't actually want to like have to go through the whole process of finding it in the console, I can just set a conditional breakpoint near that function so that once it's been declared, then I can call it with whatever I want to. And that's a really cool. So I actually do really like using conditional breakpoints as well. So that's basically it. And then we can like, come over here and then edit it whenever we want to. So that's conditional breakpoints. And one other one, which is a log. So log is just like a breakpoint that allows us to log something. And you can basically do this from the conditional breakpoint anyway, so I usually don't use this, but you can just know it exists though. So that's very handy. And you can see the conditional breakpoint here. And it has like this little color in Firefox, so if we want to edit the condition, we can also do it here as well. And that's really nice. Now, one other thing that I wanted to say is that I actually found this recently, is these event listener breakpoints. And to be honest, most of this didn't seem that helpful to me. I kind of don't see why like a keyboard event is important. And actually, first of all, I'll say what this does. This basically, whenever there's an event listener, like do you remember those like on-click event listener or whatever? What this will do is whenever one of those event listeners gets called, it's going to go to that line of code and stop the interpreter first. And most of this I don't think is that interesting. Maybe this one, the load, because this could lead to like functions that basically are parsing query parameters, which could be good for finding stuff like client-side path traversals. So I can see stuff like unload, load especially, so whenever you load the page, could be interesting. You could see what functions trigger there. and most of these probably not that interesting. And yeah, I could see that definitely being useful. And then this also caught my eye, the one that I have open right now, which is the WebSocket one. And I thought this is super cool because back then I would spend ages trying to find these WebSocket listeners. I would dynamically statically pull the code onto my computer, run JSCout on it, and then try and find the event listener that way, trying to find where in the code. That's pretty complicated just because it's really annoying to do that. But with this, what you can do is you can just press this message button, and whenever a WebSocket message gets sent, it'll just stop the interpreter. Now, I don't think there's any WebSockets on OpenAI, so we're going to have to go to a different website. We're going to have to go here to this platform called WebSocket King. And what this is basically going to do is just allow me to test out WebSockets. So we're going to go in here, and then same thing, I'm going to pause on messages. And maybe also pause and open so you can just see it. And when we connect, you'll see that the debugger has paused right here. So this socket.open function, and whenever the socket opened, it paused right here. So now I can have a look at this e function. This is like an object. Seems like this is like a WebSocket connection. You can see here. So I can debug it straight away here. And more importantly, I want to pause on where the actual messages are. So whenever I send, you can see this onMessage function is right here, and it passes it to a different function called MTE, which is very interesting to me. And now that we've identified it, we can start putting things together. For example, let's say I wanted to put a conditional breakpoint right here, and I wanted to log whatever this actual WebSocket message is here. So we can hover over this, and you can see this is the WebSocket message right here. And you can see WebSocket.data. So let's say we add a condition here, and I want to say console.log t.data. And then I'm going to set that to false. I'm going to create that, and now I'm going to unpause this and keep running the debugger. Right, let's go to the console now. You can see it's logged it first. Now I'm going to change this to like test123, and you can see it's going to log it. So now we basically have a way to log all the WebSocket messages. And we can do other things on this. So if I like edited this condition, we could say like, t.data. Lower or something. I think it's like 2 lowercase or something in JavaScript. I think it's like this, I want to say. I don't know. I can't really remember. Let's see if that does anything. Okay, you can see I've put it to lowercase. I can perform like different operations on it. If say there was like encoding happening, let's say that this was a compressed WebSocket message. This WebSocket message was being compressed. Then if what I could do is I could create this condition here, and I could call a function that decompressed it. If I found like a decrypt function inside this code, I could call that decrypt function on it basically instantly, which I think is super nice, and I could print it out to the console. So I think that combining this and this is also interesting. You can also see the load one, which maybe I should actually start using this one more. So like refresh this page, and you can see that this function right here is being called. This is just jQuery, which is boring. Let's move to like maybe a different one. Okay, that was the only one that actually called, which is unfortunate. So you can see jQuery gets called when the function gets loaded, which is not surprising because it's a library. And yeah, this is how you can use these event listener breakpoints as well, which I think get a little bit underused. And we can have a look at these 2 other tabs as well here. So we have this outline tab, and what this is just going to do is this is just going to show us basically all of the functions that are actually inside of this of the script. So you can see onMessage is, I think, the function that we actually called last time. Oh wait, the second is jQuery, so this is something else. Oh wait, no, this is the tracker endpoint that I have. I actually know what this is now. Let me maybe go to a different one in that case. Let me go to this. So we have here, because it's probably gonna look more like this, where this function is called like t and stuff like that. Just purify that. Ooh, okay, there you go. And it's just going to show us it. Now there's a cool thing about this as well, is that if you go into here, it's going to show you what function that you're currently in, which can be nice to like orient yourself to see what the top level function is, because when it's like minified like this, it's kind of hard to see where like the end of it is. I think you can press Control N or Alt N. Oh, maybe not that. Oopsie, I might have done something weird. Yeah, you can press like some button to come back to the top. I don't remember what it is, but I think it's actually just easier to see like here and see what function they're currently in. So that's just the outline tab. Oh yeah, you can also copy the function, which is interesting. So if you want to like copy it there, and then you can like paste it in. Okay, that's actually nice as well. Okay, I actually didn't know about that. Just randomly right clicked on it. But yeah, that's basically all you can do, and then you can also sort it. So if you had like a function, you were looking for like function S or something, then you could sort for it here, and then here's S again. So you can do that, and then just a good old search tab. Now I recommend not searching here because this is static analysis at this point. When you're searching like this, it's more static analysis than dynamic analysis. So I recommend just pulling JS Scout and then just pulling all these files together, because if you're searching, this is only going to search files that are currently loaded inside your browser, which, because most websites use Webpack, it might not include all of them. So just to be safe, I always like using JS Scout and then going through navigating to every single page in the browser and trying to unpack the bundles, because it's just going to be a lot more thorough that way, and it's going to uncover files that people have missed, which is very important for me, obviously. Well, you can use the search tab as well. You can come in here. It's good to go for like searching quick stuff. Good thing is you can use like regex here as well. You can uppercase, you can match entire words as well. So that's really nice. Search tab. And then that's kind of it for the debugger tab. I think I've covered all the main features. Obviously, I haven't covered everything because there's a lot of stuff, but I'm just going to cover the essentials so that I'm not wasting time with stuff that's kind of you can discover yourself. But that's it for the debugger tab, probably the most important tab in the console they're going to be using, the actual JavaScript analysis. And I do hope that was helpful for you as well. Now I just want to cover one more tab very quickly, which is the storage tab. Let me go and open it instead. Maybe they might have more storage here. There you go. What does the storage tab do? The storage tab is all the stuff that's going to be stored locally inside your browser by the JavaScript code. So there's different types of storage. Like inside a website, you might have the server storing stuff on SQL, so on some kind of database, where it's then like fetching it back to you. And then you might have your browser storing some local things on your actual machine. What things might be stored on a machine? Well, typically things that relate to just like you and some kind of cosmetic things. For example, if you for example have like an onboarding process on a website, like say it's like Stripe or something, it'll tell you to like this tutorial how to use the website. If the user has already seen that tutorial, there could be like a boolean saved inside the local storage that this user has already seen this, so don't show it to them again. And inside the JavaScript, it'll be like local storage dot get this, and if this is true, then don't show the page. So that's what stuff in local storage tends to be. Other things like analytics, because they're mostly client side, so you might see like Sentry here, you might see Datadog here, you might see that kind of stuff here. You probably see like Google trackers trying to gather all the information about you, so you'll probably see that as well. This DB tends to be for structured data. So if the website is collecting like specific data, for example, I saw one where it was collecting like every single site, every single like page on the site that you visited, and it stored it with like a timestamp, the name of the page, etc. You can use a local database for that, which is used for this. And then there's the local storage, which is like the cache. Cookies also falls under this, so cookies tends to be used more for authentication on the client side, so storing authentication tokens and stuff like that, and it's stored here. So this is also here. It's also in the HTTP proxy, obviously, but what you can do here is you can see the different cookie attributes here. It's like HTTP only, secure, same site, last accessed. Now we have to like honestly say that this last accessed will be so much more useful if you could right click it and actually see where in the code it was accessed. I think that actually should be a feature where this will like save where in the code it was accessed. That would be in the save feature. Firefox, if any Firefox developers are listening, please add that in. That would be amazing. Well, yeah. Anyway, this here you have this cache. You have more stuff like here. This looks like some kind of tracking thing, and your session ID, stuff like this. That's probably used by the. Sometimes this is used by like the JavaScript code to create paths as well. And also remember, if you have a cross-site scripting vulnerability, then you can read all of this. So if there's like something sensitive here, well, not the cookies, but usually not the cookies if there's secure cookies here. But You can read stuff like the local storage fine. So if there's any like access tokens here, you can just yoink that and show impact. That's great. I don't know if you could read the session storage or the cache storage, but you can definitely read the DB and the local storage. So that's something to remember. So if you have a cross-site scripting vulnerability, you can show impact like that. And also sometimes there's feature flags stored in here. So I had a video about feature flags, where basically how to like enable all the beta features and all like the A/B tests and stuff like that in these websites. Basically discover all like the hidden stuff that's like in the background. And sometimes it's stored here in the local storage. So you might see like a file, like a feature flag here, which is like usually a Boolean true or false or 0, 1. So you can like enable it here if you want to. That's mainly what the storage tab is used for. But yeah, don't sleep on it either though. There's some stuff that gets stored in that's actually relevant to the website. And you can like basically like take this and like see if you can find it anywhere inside the actual web page. Try and find something like this. You can see maybe it's being pulled and actually being used. So that could be something you can do. But yeah, that's pretty much the local storage for you. And I think that's it for the DevTools. So that's a real comprehensive guide. If you understood everything, I think that's gonna set you in like a lot further than most people are right now. And I think it's also a very important skill for you to learn as well. And yeah, I hope you enjoyed this video covering how to use the browser DevTools, specifically the Firefox DevTools. And I think it's a very important skill to know for any hacker. It's quite essential. Even if you're server-side hacker, then you really need this to find those endpoints, to understand functions, how they work, and how that relates to the server side. If you're a client-side hacker, then obviously it's even more important, because basically your whole job is to look for these vulnerabilities in the client-side code, debug them, and see how you can basically change them and inject malicious input into them. It's also a part of my bug bounty that I'm working on at the moment, something that I'm trying to go for and really improve on, especially client-side vulnerabilities, because I feel like I have been sleeping a little bit on them. I do slack a little bit on them. They are quite hard as well to find. They are a little bit more technical than some of the server-side vulnerabilities, so I do want to get better at them, and I also encourage you to do the same. I apologize for no video last week. I was at a judo competition, so I was a little bit busy there, but from now on I'm gonna try and post one video a week every Sunday, so do stay tuned. Sunday at around 3 p.m. I'll be posting videos, so I'm going to try and keep that schedule up. And yeah, that's it for me. Thanks for watching and happy hunting.